Hello, Mr. Myasis here, and I am here with my other video on 1-3. This is 1-3b, limits at infinity. So this is different than the one that I did previously with infinite limits. These are limits as they actually approach infinity. So when we were looking at infinite limits, we saw that those infinite limits were vertical asymptotes. Well, horizontal asymptotes can be described by the limit as x approaches infinity. So it's what's happening at the end of the graph, the end behavior, if you will. So the end behavior is really about the horizontal asymptotes. Now, if you remember from pre-calculus, there's a little trick to finding the horizontal asymptotes. What you're going to do is you're going to look for large values of x, you're going to look at the highest degree, either on the numerator or the denominator. And whichever one dominates it is the one that's going to kind of win. Now, if they're equal, like this one is 4 and 4, then the horizontal asymptote is going to be the coefficients of that highest degree. So we're going to have 5 over 10, right? 5 over 10. We can write that as 1/2. That would be our horizontal asymptote. Here, since the denominator is a much bigger power than the numerator, we're going to have a horizontal asymptote of y equals 0. And here, since the numerator has a higher degree than the denominator, this has no horizontal asymptote. Now, the way we see that in calculus, and there's an old kind of algebraic rule that you would do, and you would divide everything by the highest power of x. And what that ends up doing is, if you think about the limit as x approaches infinity of 1 over x, and let's go positive infinity, this is going to get, this value here is going to get really, 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 really big. And if the value here gets really, 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 really big, then the entire thing gets really, 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 really small. In fact, it gets closer and closer to 0. And we knew that anyway because this has a horizontal asymptote of 0. So really, when we're doing limits at infinity, we can really think about them as their horizontal asymptote. So here, we have the same one here. So our limit as x approaches infinity is going to be our horizontal asymptote, which is 1/2. Here we have the limit as x approaches negative infinity, which is going to be our horizontal asymptote again, which is 0 because the denominator was bigger. And here we don't have one, so it's either going to approach positive infinity or negative infinity. And we got to kind of think about what's going on. So we're going to look at which one is going to be dominant. And notice that when we plug in very large values, we're going to be positive here. And here we're going to have very large values also, which is positive. So we're going to have a positive infinity. It's okay also to say it doesn't exist. So what about for number 12 here? Number 12, we have an x and an x squared, which together is going to give me a 2x cubed. And here we're going to have 9x squared and an x, which is going to give me 9x cubed. And since this highest power are equal, we're going to get 2/9 as my limit. And that's all you got to do for that. All right? Pretty simple, right? Now, sometimes square roots have they have 2 horizontal asymptotes. So I'll show you I'll show you how that happens. When we plug very large values of x in here, notice a square root. Now we're only looking, this is kind of insignificant when we're talking about large values of x, this -3. So we're only looking at this part here. So the square root of 4x squared is going to give me 2x. All right? Now, for very large positive values, this is going to be positive, right? So this top is always going to be positive, and the bottom is always going to be positive. So if we end up with something like this, that these are the same, okay, these are the same, then our horizontal asymptote is going to be positive too. However, in this case, we have the same situation here, so we've got a 2x and x here. But this is always going to be positive on top. But the bottom here, as we approach negative infinity, this is going to be a negative value. So we're actually going to -2 because this value is always going to be negative. So we're going to have 2 horizontal asymptotes. All right, so that's how we can see horizontal asymptotes associated with limits that as x approaches infinity. All right, a really kind of quick and easy way to find these limits.